Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. Yesterday, in chapter number 3, Chemical Reactions and Equations, we have studied how to balance a chemical equation stepwise, and we had studied the 4 types of chemical reactions. Today, as usual, in the first 5 minutes, we are going to revise the types of chemical reactions which we have studied yesterday. Then we will study the different factors which affect the rate of a chemical reaction, and towards the end we will study the phenomenon or an event of corrosion. So let us first start with the revision part. So the first equation which we have studied yesterday was combination reaction. Combination. I have told you the we can say meaning is hidden in the name of the reaction itself. Combination, when two or more reactants combine in a reaction to form a single product, it is called a combination reactions. Different reactions we have seen under that. Magnesium remain burns with oxygen from the air, forming magnesium oxide. Ammonia gas reacts with gaseous HCl, forming ammonium chloride. Calcium oxide, when treated with water, forms calcium hydroxide with the liberation of heat. So when two or more reactants they combine, they come together yielding a single product, then you call such a reaction combination reaction. The next which we had studied was decomposition reaction. Exactly opposite. The chemical reaction in which two or more products are formed from a single reactant is called decomposition reaction. Breaking down of a single reactant into two or more products. Different examples we had seen. Here you can see water being broken down into hydrogen gas and oxygen gas. And the two types of decomposition reaction we had studied. The first one was thermal decomposition, where supply of heat to carry out the reaction was done, and the second type is by passing electric current, which was known as electrolysis. Lysis means breaking down, electro with the supply of electric current. The third type of reaction which we had studied was displacement reaction. Displacement, we had taken a very good example of two notorious and two good students of the class, how they can change their place, how a less reactive child is replaced by a highly reactive child. So the reaction in which the place of the ion of a less reactive element in a compound is taken by another more reactive element by the formation of its own ions is called displacement reaction. And towards the end we had studied double displacement reaction. Here in this reaction a precipitate is formed. So the reaction in which the ions in the reactants are exchanged to form a precipitate are called double displacement reactions. And towards the end we had studied endothermic and exothermic reaction. Endothermic and exothermic means you have always seen that in a chemical reaction, to bring about a reaction, either heat has to be supplied from outside or heat is given out in the reaction. So when heat is taken up, when heat has to be supplied, such a type of reaction is called as endothermic reaction. A chemical reaction in which heat is absorbed is termed as endothermic reaction. Calcium carbonate on strong heating decomposes into calcium oxide and carbon dioxide gas. We had studied this equation under decomposition reaction. And a chemical reaction in which heat energy is given out, that is known as exothermic reaction. Calcium oxide, when treated with water, forms calcium hydroxide with the liberation of large amount of heat. So a very small tip I had given you over here. If you see heat on the side of the reactants or above the arrow, then it is endothermic, and if heat is seen on the side of the products, then the equation is exothermic equation or reaction. till endothermic and exothermic we had seen yesterday. Now let us move towards the next topic. The very important topic is the factors which affect the rate of a chemical reaction. For any chemical reaction to be carried out, there are certain factors, there are certain conditions which have to be supplied to foster up the rate of the reaction, to bring about the reaction at a very quick or a speedy rate. So which are that factors? Now suppose we take a very good example. If you want to score good marks in the exam, that is the chemical reaction which has to be brought about, there are different factors which are going to affect it. Which will be the first factor? Your concentration of the studies. Which will be the second factor? The explanation, the notes which are provided from the school. Which will be the third factor? The conditions around you when you sit to study. So these are the different factors which are affecting your study. So for a chemical reaction, the first factor which affects is the nature of the reactants. You all know reactants are the ones who combine, who decompose to give the products. So their nature is very important. Now nature or reactivity of reactants, it influences the rate of a chemical reaction. Suppose you take an example here which is given in the textbook. There are two elements, aluminium and zinc. When both of them are treated with dilute HCl, when a metal, now element or a metal you can call, aluminium, zinc, when treated with acid, you know H2 gas, that is hydrogen gas, will be liberated and water soluble salts of these metals will be formed. But the reaction of aluminium will take place faster as compared to zinc. Why? Because aluminium here is more reactive than zinc, and hence the reaction of aluminium with dilute hydrochloric acid takes place faster as compared to zinc. So who is playing an active role over here? It is the nature of the reactants. Depending upon the reactivity of the reactants which are taking part in the reaction, your reaction occurs at a slow or fast speed. Suppose there are two children who are running in a race. The first one is very active, who has done a lot of practice as compared to the other child. The first child who is very active will run fast. So similarly, the reactants, the nature, the reactivity of the reactants, it is going to affect or influence the rate of a chemical reaction. The next is size of particles of reactants. Here it is very simple. Size of the particles. To understand this factor, I will take a very small example. You take water in 2 glasses. Take a tablespoon of granular sugar, in the sugars which is in the granular form, and in the other spoon you take powdered sugar. The sugar you have made powder from it in the mixer or the grinder. In the first glass of water, take equal amounts of water. In the first glass you add granular sugar, and in the other glass of water you add powdered sugar and stir both simultaneously. In which case will you see that the sugar has dissolved at an early rate or fast? Surely it will be in the second glass where you have added powdered sugar. Why? The same amount of water was taken. Stirring also was done simultaneously. It is sugar only, but the powdered sugar, here the particles of the reactants is small, and smaller the size of the particles, then faster is the rate of the reaction. So similarly, here also the same technique is applied. Smaller the size of the reactant particles, higher is the rate of the reaction. Next is concentration of the reactants. Concentration, how concentrated it is. Here also we will take an example from the classroom. Here there are, in one class there are 30 students who are sitting. In the other class there are more than 60 students sitting. As soon as the bell rings and the children come to know that somewhere on the ground or somewhere around there is some bomb which is kept or some fire, something has taken place. some disaster, small disaster has taken place and you are told to run out of the class and move out. Then which class will move out faster? The class which will be having less number of students will move out faster. So this is a small example. Here it is exactly opposite. Rate of the reaction is proportional to the concentration of the reactants. Now if you take dilute HCl and if you take concentrated HCl and both you try to carry out the reaction with CaCO3, that is calcium carbonate, you will see that dilute HCl will react slowly and then you will see that calcium carbonate disappears slowly. Whereas on the other hand, the reaction with concentrated HCl will take place at a faster rate, and hence we say that concentrated acid, it reacts faster than dilute acid. What does this mean? The rate of the reaction is proportional to the concentration of reactants. Next, the next factor which is affecting is temperature of the reaction. For most of the reactions to be carried out, temperature is required, especially when you have studied about the decomposition reaction. Then we have seen how the decomposition of limestone is carried out by heating the reactant. So from this what we can learn, that the rate of the reaction increases on increasing the temperature. And the last factor which affects the rate of a chemical reaction is presence of a catalyst. What do you mean by this term, by this word catalyst? The substance in whose presence the rate of a chemical reaction changes without causing any chemical change to it is called a catalyst. A good example from the classroom again. Here there is a monitor which is appointed for every class. What is the role of the monitor? In the absence of teacher, the monitor takes care of the class in various ways. The monitor takes the attendance of the students. The monitor is told by the teacher to collect the books during book correction. So monitor keeps the class quiet till the first teacher, after the first teacher leaves and the next period teacher enters. So this is all the work of the monitor. So here the monitor has no rights to interfere with the main activities. That is, the monitor has no rights to correct the books. The monitor has no right to give any remarks or scold the children. But that monitor is helping the teacher to keep the class quiet and to carry out the activities at a faster rate. Means if the books are collected beforehand, then it becomes easier for the teacher to correct it. So similarly, the catalyst is a substance which is added in any chemical reaction to speed up the rate of the reaction, but that substance does not interfere in the reaction. Such a substance is called as a catalyst. So here an example is, on heating potassium chlorate, that is KClO3, it decomposes to form KCl, that is potassium chloride, with the liberation of oxygen. Now the rate of this reaction, it neither increases by reducing the particle size nor by increasing the reaction temperature. So in this case, to bring about this reaction of decomposition, you have to add manganese dioxide, that is MnO2, which is nothing but a catalyst. As soon as MnO2 is added, the rate of decomposition, the rate of the reaction increases. But manganese dioxide will not interfere, it will not bring about any chemical change in the reaction. One more example is decomposition of hydrogen peroxide into water and oxygen. It takes place slowly at room temperature, but the same reaction will occur at a faster rate on adding manganese dioxide, that is MnO2, which is nothing but a catalyst. As soon as this catalyst is added, the reaction of decomposition of H2O2, that is hydrogen peroxide, will take place faster. So these are the different factors which affect the rate of a chemical reaction. Now one small example I will give you how the questions can be asked in the exam. about the catalyst they can ask, or they can give you an example. Take two test tubes containing dilute HCl, and in the first test tube add zinc granules, and in the other test tube add zinc powder. Which reaction will take place faster and why? Such logical questions can be asked in the exam. Now here, how you are going to answer? The first thing you will answer is the reaction with powdered zinc will take place fast as compared to your granular zinc. If it is for 3 marks, 1 mark you will get over here. Second is they have asked why. Why? Because smaller the size of the particles of reactants, higher is the rate of the reaction. So the reaction surely with zinc powder will take place fast. And third mark you will get for writing the balanced equation. So zinc, when reacts with HCl, it forms zinc chloride with the liberation of hydrogen gas. So such type of questions will be asked on this part of the chapter, that is the factors affecting rate of a chemical reaction. The first factor is nature of the reactants, second is size of the particles of reactants, third is concentration of the reactants, fourth factor is temperature, and the fifth one is catalyst. Now let us move towards the next part of the chapter, the other two types of reactions, oxidation and reduction reaction. Oxidation and reduction. In the first case, you can see, as I have told you, the meaning is hidden again in the word oxidation. The chemical reaction in which a reactant combines with oxygen or loses hydrogen to form the product is called oxidation reaction. So whenever any reactant it combines with oxygen, what we say that the oxidation reaction has taken place. So the chemical reaction in which a reactant combines either with oxygen or loses hydrogen, then it is called oxidation reaction. Now the different examples of oxidation reaction we will see. In the first case, we have seen this example under combination. So 2Mg, that is magnesium ribbon, when burns in air, combines with oxygen from the air, forming magnesium oxide. So it is an example of oxidation reaction because you can see the reactant magnesium combining with oxygen. Similarly, if you see the next reaction, carbon combines with oxygen in the air, means carbon when burnt in air, it combines with oxygen forming carbon dioxide gas. So a reactant carbon combining with oxygen, oxidation. In the third case, you can see MgH2. It is decomposing into Mg plus H2. So hydrogen is lost. So oxidation. Similarly, for the next equation, CH3 single bond CH3, it forms CH2 double bond CH2 with the liberation of hydrogen. So hydrogen is lost. So the reaction in which either you can see the hydrogen losing of hydrogen or combining of oxygen from the reactant side, such a reaction you call as oxidation reaction. Now some oxidation reactions, they are brought about by the use of specific chemical substances. We take up an example over here. CH3 single bond CH2 single bond OH, that is ethyl alcohol. It undergoes oxidation forming acetic acid but does not undergo oxidation naturally on its own. Here you can see acidic potassium dichromate, that is K2Cr2O7. It is potassium dichromate. It makes the oxygen available for the oxidation of the reactant ethyl alcohol. So such chemical substances, here you can see the oxygen is made available by whom? It is made available by this potassium dichromate. So such chemical substances which bring about an oxidation reaction by making oxygen available, they are called as oxidants or oxidizing agents. You have to purchase a good flat. Then what you do? You take the help of the agent. What is the work of the agent? To make a good flat with a good budget available to you. You are not directly going and contacting the person who wants to sell the flat and all. So it is the agent who is making that flat available to you. So here also this acidified potassium dichromate, it is making this acidic potassium dichromate is making the oxygen available to ethyl alcohol to bring about oxidation, and such substances are called as oxidants or oxidizing agents. Now, just now we have seen how potassium, even the potassium permanganate, that is KMnO4, it is a chemical oxidant. We will just take up one example. Here you can see KMnO4, that is potassium permanganate. It combines with FeSO4, that is iron or ferrous sulfate, plus H2SO4, that is sulfuric acid, to form potassium sulfate K2SO4 plus MnSO4 plus Fe2SO4 thrice plus water. So here FeSO4, that is ferrous sulfate, it is transformed into ferric sulfate, that is Fe2SO4 thrice. Now how this conversion you can call as an oxidation reaction, let us see. So you can see FeSO4, it forms Fe2SO4 thrice. So the ionic reaction over here is Fe2 plus sulfate, that is SO4 2 minus, it will form 2Fe3 plus 3SO4 2 minus. So the net change which is taking place in the above conversion, it is shown by the net ionic reaction. So what is the net ionic reaction? Fe2 plus, that is ferrous, getting converted into Fe3 plus, that is ferric. So what you can infer over here is the net ionic reaction represents the oxidation which is brought about by the chemical oxidant. Which chemical oxidant? KMnO4, that is potassium permanganate. So the chemical reactions, you can say, from this what we understand, a new definition of oxidation. Oxidation also means losing one or more electrons. Previously we have seen that oxidation is the reactant combining with oxygen or losing hydrogen. But one more definition here we have studied, that oxidation also means losing one or more electrons. Our next reaction is reduction, exactly opposite of oxidation. So the chemical reactions in which reactants gain hydrogen or lose oxygen is called reduction reaction. For oxidation it was reactants gain oxygen, lose hydrogen. Here it is exactly vice versa. So an example is mercuric oxide, that is HgO. It forms Hg, mercury plus O2. So here oxygen is lost from the reactant side. Such an example you call as reduction reaction. The next is redox. Redox, the word again is telling you reduction, oxidation taking place together. So the name redox reaction. Here you can see one example taken. Copper oxide combines with hydrogen forming copper and water. So copper oxide, here you can see in this reaction an oxygen atom goes away, is lost by copper oxide. So what you can say, when an oxygen is lost, then copper oxide is forming copper by losing oxygen. So here copper oxide is getting reduced, a reduction reaction is taking place. Whereas this hydrogen, this reactant hydrogen, you can see taking up this oxygen and forming water. So oxidation of hydrogen is taking place. So in a single chemical reaction, you can see oxidation and reduction taking place simultaneously. Such a type of chemical reaction you call as redox reaction. So a chemical reaction in which oxidation and reduction take place simultaneously at the same time is called redox reaction. So the reductant is oxidized here by the oxidant and the oxidant is reduced by the reductant. So here we complete all the types of reactions: combination, displacement, decomposition, double displacement, endothermic, exothermic, oxidation, reduction and redox. So many reactions you have to study. At the same time, you have to concentrate on which type of reaction it is. As I have already informed you, a reaction might be placed ahead of you. You have to identify which reaction it is. Now here there will be a little bit confusion. If you take an example, just we will go to the previous slide. If you take this example of oxidation, Mg plus O2 forming MgO. So if this reaction is placed ahead of you and you are told to identify which reaction it is, you will have confusion. Now it is combining with oxygen, so it can be called as oxidation, or two reactants are combining and forming one product, so it can be combination. So both are correct. Both are logically correct. Only the thing is proper explanation should be provided from your side. From if you are saying that the above reaction is, suppose this reaction is given and you are told to identify and why. So identifying, suppose I am saying that the above reaction is combination reaction because two reactants, that is magnesium, is combining with oxygen forming a single product, magnesium oxide. Some other child will write the above reaction is oxidation reaction. The reactant magnesium is combining with oxygen forming magnesium oxide. Both are correct. So here don't have the confusion. If both the same equation belongs to two types, then which type to mention. The last topic to end this chapter is corrosion. Especially in the rainy season, you see in the presence of moisture in the atmosphere, mostly the iron articles or the articles which are made up of different metals, they undergo this process of corrosion or rusting. You can see the key of iron getting rusted. This old vehicles, it has lost its shine due to the formation of this reddish colored rust on the surface of iron metal. So this, you can say, a certain type of reddish colored solid layer collects on the metallic surface, especially here it is iron grills, you can see, and this layer is called as rust, and the chemical formula of rust is Fe2O3.X, that is H2O, water of crystallization. Fe2O3, why? Because iron combining with oxygen forming this rust, that is Fe2O3. Now this rust on the iron, does not form by a very simple reaction of oxygen which is coming in contact with iron surface. So here the rust is formed by an electrochemical reaction which we are going to study ahead. So the different regions on the surface of the iron, they become the anode and the cathode. You have studied about this topic in the 9th standard under chapter number 5, electrochemical reaction. So first is Fe. That is, iron is oxidized to Fe2 plus in the anode region. So Fe ion in the solid form getting oxidized to Fe2 plus with the liberation of 2 electrons. O2, that is oxygen from the air, is reduced to form water in the cathode region. So O2 in the gaseous form reacts with hydrogen in the aqueous form to form H2O, that is water. So when this Fe2 plus ions, they migrate from the anode region, they react with this water and further they get oxidized to form Fe3 plus ions. Don't get confused. You can see first reaction takes place in the anode region where your iron in the solid form, it gets converted or oxidized to Fe2 plus. At the same time in the cathode region, now here both the regions are on the surface of iron only. One is anode, other is cathode. So oxygen from the air in the gaseous form, it combines with hydrogen forming water, and then when this Fe2 plus ions, they will migrate, they will move from the anode region, they will come in contact with this water and they will get oxidized to form Fe3 plus ions, and then a reddish colored hydrated oxide is formed from the Fe3 plus ions which is known as rust, and you can see it collecting on the surface of iron metal. So what is this corrosion? Now here you can see that iron has become corroded or iron metal is corroded. So the different components, due to the various components of the atmosphere, oxidation of metals, it is not only about iron. Different metals undergo oxidation. So it resulting in the damage of the metals. This is called corrosion. Iron rusts and a reddish colored layer is collected on it. This process is known as corrosion of iron. So this is what you can say also a chemical reaction, and undesirable, which is not required, disadvantageous, causing damage. When iron articles get corroded, they will not be very useful. Your rickshaws or your grills of the windows and all, when they get corroded, then the rust, you can just see when you touch the your hands on the grill and all, that rust will be seen sticking to your hand. So it is an undesirable, unfavorable chemical change. The next topic is rancidity. Rancidity means what? When we use old leftover cooking oil for making any new foodstuffs, then what you see, it is found to have a very dirty smell, and that is known as rancidity. So the process in which the taste and the smell of the food gets spoiled is called rancidity, and hence it is said, do not eat the oily foodstuffs from outside. The people who prepare this vadas and all, they are not going to use different oils every day. Whatever oil is left over, they are going to store it and reuse it again the next day. And after a certain period of time, that oil will start giving a very dirty smell, and the taste of the food which is cooked in it also gets spoiled, and then we say that it has turned rancid. So when oil or ghee is left aside for a long period of time, or fried food is left aside, then it undergoes air oxidation. It combines with oxygen from the air and becomes rancid. So how you can prevent this rancidity? Rancidity in the foodstuffs cooked in oil or ghee is prevented by using antioxidants against the process of oxidation, or the process of oxidation can be lowered down, can be slowed down by storing it in airtight containers. You can see this packet of kurkure shown over here. If you just see in the ingredient side, you will see the presence of antioxidants. Or you can see your parents storing the food grains or oil properly in airtight containers. So here what happens when it is airtight? The reaction or the contact with oxygen is lost, and your foodstuffs, oils and all, they remain in a good condition, and the process of rancidity is lowered. You cannot say it is prevented, it is lowered, and hence it is always advisable to eat especially the oily foodstuffs prepared at home, even though outside foodstuff may be very tasty, but surely they are very risky and harmful for your health. With this, we complete with the explanation of chapter number 3, chemical reactions and equations. In our next lecture on Thursday, we are going to start with the discussion of textual exercise. So before attending the next session, see to it that at least you go through the exercise and try to get some amount of answers on your own. Thank you, dear children.